Okay, so today I just want to do a quick video on the Pythagoras theorem, right? So Pythagoras, I would think, is one of the most famous theorems that there is in modern day mathematics, and I'm sure you must have come across it by now in grade 8 or 9, and some schools even do it in grade 7. So let's have a look. So what does this all entail? Pythagoras. Pythagoras' theorem said that in a right angle triangle, right? So in a right angle triangle, that okay, let's before we get to the actual definition, so let's just see what we can do. Let's have a look at the right angle triangle. Okay, so here's one. So here we have a right angle triangle, right? So let's name the sides. This side here, the longest side, right, will be called the hypotenuse. Hypotenuse, not hippopotamus. Um, yeah. So hypotenuse, let's just take that out. Okay. So we have this as the hypotenuse. This is a side and that's another side and this is 90 degrees. Okay, so what Pythagoras' theorem says is that the hypotenuse squared, right, is equal to, let's call this x and that's y. He said the hypotenuse squared will be equal to x squared plus y squared in any right angle triangle. So for example, if we had a right angle triangle over here, right? Let's see if we can get another one in. Let's just change the colors. Okay. So let's say we had one like this. Say we had one here, right? And let's call the side 3 and let's measure this as 4 and let's call that hypotenuse. Now according to Pythagoras, right, he said that the hypotenuse squared will be equal to this side squared plus that side squared. So let's put that into practice. So it will be, let's say, 3 squared plus 4 squared. So then let's just get some more space. Okay, so we see that the hypotenuse squared will be equal to the side squared plus that side squared, which is 3 squared plus 4 squared. Now 3 squared is going to be 9, and that does not look like a 9. So 3 squared is going to be 9 plus 4 squared, which is 16, right? And 9 plus 16 gives us 25. Now hypotenuse squared is 25, not the hypotenuse. Now to get rid of the square here, right, we have to do the opposite or the inverse operation. So to get rid of that, we'll have to take the square root of that and the square root of that. So the square root of something squared would just be itself again, and the square root of 25 we know as 5. So a triangle, okay, let me not attempt to draw a triangle. So a triangle over here, right? The hypotenuse we found out to be as 4. No, I mean 5, sorry. So a 3, 4, 5 triangle. So that's basically, uh, this is one of the special Pythagoras triangles. You'll get more as we come across. But it's just a quick review video. So that's basically that. So let's say that's finding the hypotenuse. But let's say, for example, we're not given the hypotenuse and we're given, for example, another side. Right? So let's say we're given this as 5 and this as 3. And we are asked to find x, for example. So the theorem says that hypotenuse squared is equal to x squared plus y squared. Right? So let's fill in what we know. Whenever we're doing math, always fill in what you have already and write down what you know. So hypotenuse squared, hypotenuse remember is the longer side, so in this case it's 5 squared. X squared we don't know, so we'll just have it as x squared. And y squared we have as 3. So it's plus 3 squared. So now this is a simple linear equation again. So here we have 5 squared is equal to x squared plus 3 squared. Now 5 squared is going to be 25. X squared we don't have. And 3 squared gives us 9. So now we need to solve for x over here. So let's carry that over. Let's carry the 9 over. If we take the 9 over, it's positive here. So if we take it over, it becomes negative, right? I'll do a video on equations as well, so if you're a bit lost on here, don't worry too much. That becomes 9, and this is x squared. So 25 minus 9 gives us 16x squared, and then to remember to get rid of that, we take the square root of it, so that will be 4. So x is actually equal to 4. And again, as we see from the previous video, that not the previous video, previous slide rather, that we had a 3, 4, 5 triangle, and in this case 3, 4, 5. I'll do another video in the future sometime a bit more in-depth with Pythagoras and solving more problems, but this is just a quick review video on a refresher so that we can tackle some other problems. But guys, I hope you enjoyed it, and don't forget to like, comment, and subscribe.